So now that we're simplifying roots with higher numbers than just 2, like we're no longer just doing square roots, the process is still the same. We're going to factor these numbers out, but when we're done, we're not going to look for groups of 2 things. We're going to look for groups of whatever our root is. So if we've got a cubed root, we're going to need to look for groups of 3 things because those represent the perfect cubes. So for 104, again, you can start with any factors. I'm just going to start with 52 and 2. 52 will be 26 and 2, 26, 2, and 13. So we don't include the numbers that we factored out, but just the numbers at the end of our branches. So what we have a group of is the perfect cube that is going to come out. And we have the cubed root of what left? 13. Don't forget to put your root in there, because if not, I'm going to assume that you want it to be a square root, and it's not a square root, it is a cube root. There are differences. So make sure you also don't forget to include that index of what you're using. So let's look at number 11. The cubed root of 6 times x to the 4th times y 9 times z to the 14th. So you could try to factor out 6, but it's just 2 and 3, so there's no perfect cubes inside there. So it's just going to stay underneath the cube root for right now. Then we need to do our x, y, and our z. So what happens here? In expanded form, x to the 4th is really x times x times x times x. So what we're trying to see is how many times does 3 go into that power of 4. So if you guys rewrote it in exponential form, it would be 4/3. 4/3 is really 1 and 1 left. That's what your answer is going to have, 1 outside and 1 left. If you guys wrote it in expanded form, how many groups of 3? 1. How many left? 1. So whether you can algebraically understand that 3 goes into 4 one time with 1 left, or you want to physically write out those x's and circle your groups, either way is fine. But we have one perfect cubed group of x's in there, and one remaining that's going to stay underneath the radical. So then we do the y's. How many times does 3 go into 9? 3 times. That one's perfect, so we'll just leave that, nothing underneath the radical. But then z to the 14th, how many times does 3 go into 14? And it doesn't hurt to write out, it's just more time consuming, but if it makes sense to you, just do it. Write out the 14 z's multiplied together. That's what z to the 14th power is. I know that 14/3 is 4 and 2/3, but if you wrote them all out and found the groups of 3, we should have 4 groups and 2 left. So z to the 4th and z squared underneath. So that would be our simplified answer to number 11. So for 10 and 12, we're not going to simplify something in exponential form normally, so we're just going to rewrite both of these in radical form. So if this is 625 z to the 12th, all to the 1/3 power, if we rewrote this as the third root or cubed root of all of this, 625 z to the 12th, then it's just like the one we just did. So you can always check to see if 625 is a perfect cube root. If it is, it's just that value. But if not, we need to factor this. So I'll start by factoring it, 125 and 5. 125 is 25 and 5. 25, 5 and 5. So we're looking for a group of 3 things. We've got one of them. This one is not going to be included because then that would be 4, and we don't want 4. So, one perfect cubed root of 5 outside, and there's one single 5 left underneath. And then how many times for the z does 3 go into 12? 4. So 5z to the 4th. Nothing left underneath because it goes in evenly. So let's do the same thing for number 12. Rewrite it in radical form. So this is going to be the square root of 32m to the 6th n to the 30th. And we don't generally write square root, but if you want to put the 2 in there, you can. So 32, there's not a perfect square root of that number, so let's factor it. 16 and 2, or 8 and 4. Factor it all the way down. So we're looking for groups of 2 things. It's a square root. So group, loner. So 2 groups is going to be 2 times 2 outside and 1, 2 underneath. So this becomes 4 outside, square root of 2 still left. So let's do our m's. 2 goes into 6 how many times? 3 evenly. 2 goes into 30 how many times? 15 evenly. So 4 times m to the 3rd times n to the 15 square root 2 would be our simplified answer here. We've pulled out all of those perfect roots within each expression. And that's all you're doing every single time when you're simplifying a radical expression. Finding those perfect roots given whatever root you're working with.